Have you ever stopped to think about what's happening inside your body, like right now, on a microscopic level? Because every single one of your trillions of cells is in this constant, epic battle for survival. In this explainer, we're going to follow the incredible story of just one of those cells and see how it fights to stay alive against all odds. So here's the journey we're going to take. We'll start with a cell just living its best life in perfect balance. Then, we'll look at the 5 clever tricks it has up its sleeve to adapt when things get stressful. We'll see what happens when that stress is just too much, and we'll explore the 2 very different ways a cell's story can end. And finally, we'll zoom out and connect all of this back to the big picture, our own health. All right, let's start at square one, a cell's normal, everyday world. This is its happy place, a state of perfect balance called homeostasis. And honestly, it's the foundation for everything else we're going to talk about. Homeostasis is basically the cell's main goal in life. It's this sweet spot where everything from its temperature to its energy supply is just right. All systems are go. But this isn't a lazy, resting state. It's more like a tightrope walker, constantly making these tiny adjustments to keep everything perfectly balanced. It's a full-time job. And that's the big question, right? Because life is stressful, for ourselves just as much as for us. When things get tough, a cell can't just, pack a bag and move to a new neighborhood. It's got to stand its ground and adapt, or it's going to die. So how does a cell fight back? This is where it gets really cool. It has this incredible toolkit for survival. When a threat shows up, the cell doesn't just panic. It pulls out one of 5 primary strategies to adapt and keep going. And here they are. The cell can shrink, grow, multiply, or even completely change its job description. And that last one? Well, that's when things start to get disorganized. Let's break down what each of these really looks like. First up, atrophy. The best way to think about this is like a factory during a recession. To survive, it has to downsize, right? Scale back production to save money. That's exactly what a cell does. If you're not using a muscle or if you're not getting enough nutrients, the cells shrink down to a smaller, more energy-efficient size to conserve resources. Smart. Okay, next up is a duo that people get mixed up all the time: hypertrophy and hyperplasia. Hypertrophy is when the individual cells get bigger. The classic example is a weightlifter's muscle. The cells themselves are swelling up. Hyperplasia, on the other hand, is when you just make more cells. Like when your liver gets damaged, it can actually regrow by making new cells. So one's about getting bigger, the other's about making more. Now, metaplasia is where things get really fascinating. This is when a cell literally changes its identity to deal with a threat. Think about a smoker's airway. The delicate cells there get replaced by tougher, more rugged cells that can handle the smoke. But here's the amazing part. It's reversible. If the person quits smoking, the cells can actually change back. But our last adaptation, dysplasia. This is where things take a serious turn. This isn't a neat, organized change anymore. The cells become a mess. They're all different sizes and shapes. The organization just falls apart. This is the cells starting to lose control, and it's a huge warning sign that we call a precancerous state. So what happens when all those clever adaptations just aren't enough? When the stress is too intense or goes on for too long? Well, the cell crosses a critical line. It goes from adapting to being actively injured. And this is the point of no return. So who are the usual suspects? What's pushing these cells over the edge? Well, the biggest one is hypoxia, just a lack of oxygen. But it could be anything, really. Physical damage, toxins, viruses and bacteria, even our own immune system going haywire. Now, not every injury is a death sentence. With what we call reversible injury, the cell might swell up a bit, but if you take away the stressor, it can bounce back. But with irreversible injury, a line has been crossed. The cell's outer wall, its membrane, starts to break down. Once that happens, there's no going back. The cell's fate is sealed. And that brings us to the final chapter in our little cell's story, death. But even here, there's a choice. A cell can die in one of 2 very different ways. Yeah, a tale of 2 deaths. On one hand, you have necrosis. This is a messy, chaotic death caused by a major injury. Think of it like a building being demolished with dynamite. It explodes and debris damages the whole neighborhood. On the other hand, you have apoptosis. This is programmed cell death. It's a clean, quiet, controlled deconstruction where the cell carefully takes itself apart without bothering any of its neighbors. This quote just nails it. Necrosis is a chaotic explosion. It causes a big mess and triggers inflammation. The body's emergency services have to rush in to clean it up. Apoptosis is so quiet and orderly, the body barely even notices. It's the cell's way of making a graceful exit. And even that messy demolition, necrosis, comes in different flavors. In the heart, it's coagulative, and the tissue stays firm. But in the brain, it's liquefactive. The tissue literally turns to liquid. And with a disease like tuberculosis, you get caseous necrosis, which is described as having a cheese-like look. It's a pretty graphic reminder of how these tiny events have huge consequences we can actually see. Okay, so we've been super zoomed in on the life and death of one cell. But why does any of this microscopic drama matter? Well, let's pull the camera back. Because when this story happens trillions of times over, it becomes the story of you. The process of aging itself is, at its core, a cellular story. It's the result of a lifetime of wear and tear, all those little stresses and injuries we just talked about. Over time, our cells just get tired. They slowly lose their ability to fix themselves, and their performance starts to decline. And what's really humbling is how much we still have to learn. Get this. Take high blood pressure. It affects millions of people. In a whopping 90% of cases, doctors call it idiopathic, which is a fancy way of saying they don't know the exact cellular cause. It's a huge reminder that so many of our biggest health problems start with these tiny, invisible battles. So, at the end of the day, here's the bottom line. The health of your entire body is built on the health of its individual cells. Every single disease, every sign of getting older, it all starts as a small disruption to that perfect balance, that homeostasis we talked about at the beginning. This is our own life story, just written in a microscopic language. And that leaves us with one last thing to think about. If this constant, incredible fight for balance is happening inside you every second of every day, what does that mean for how we live our lives? What choices can we make to help ourselves win their fight?